So today I'm just gonna kind of introduce my project a little. Um, my name is Sarthak, and kind of working on a project which basically a 2D platformer from scratch that I kind of want to develop just for fun. And so I'll be showing right now. I'm showing what I have right now. Let me set this project. If I run this right now, it's pretty basic. We just have like a main character, the ability to kind of move up, down, left, right. There's a little bit of gravity, a little bit of collision detection. You know, if you saw in the beginning, this block right here moved from here up here. So I guess there's like some sort of basic animation, things of that nature. And along with this, obviously, there's just going to be like a whole world. So, and I'm not going to hard code the entire world. So I'm also kind of doing another project sort of side by side, which is essentially a map editor where this is essentially the world map, and I'm essentially going to be placing the different items I want to kind of show so that I can kind of just export this as a file and read it in the game engine. Obviously, you see there's a bug, but so essentially that's what I'm working on right now. Um, Probably going to kind of go through the project a little since it's been a couple days since I've worked on this and kind of comment some stuff, just see maybe organize some stuff. Obviously, you saw that there's a bug over there that I have to fix, and sort of just kind of work through some of the problems. Um, so, I'm gonna be working on the editor right now because the game itself, for the most part, it's gonna be kind of simple. The main thing I have to do right now is to create the editor and then kind of just export the kind of the world data out in a file. So that's the first step before I even go back to working on the game. So let's see. The way this is structured is all the code is in the source folder right here. And let's see, so we start off in main. Over here we have some key state data, which is global. The debug, rectangle rendering. I'll kind of explain that after. I also need to see what exactly I'm using that for. So, but over here we have the application, which essentially is just application data. Uh, which is essentially if it's running, the window IO, the frame buffer object, as well as some OpenGL data for the frame buffer object, and some debug information as well. So for here, then we have the mouse state, we initialize application. So by initializing SDL, make the app, set it to running. We initialize some of the rectangle data, which essentially, because it's a 2D game, everything is basically just rectangles. And so we initialize some of the data, like the VBO, EBO, VAO, stuff like that. We have initializing some of the frame buffer object, because essentially, and maybe this is a good thing to comment, but essentially, once again, there's the EBO, VAO, things of that nature, but essentially, the actual world data will be if I go and show, let's see, hold on. This texture right here, this is actually its own render pass. And so over here we'll be kind of placing the different items, and then we're gonna render that into a frame buffer object, and then essentially we'll take the the color buffer from that and actually show it over here in the final render pass, which includes all these other tools, which if you recognize is also just I'm GUI. So we're just gonna be showing that image. And so it makes it so that I can kind of separate the logic for the actual placing the items in the world map from the actual like other editor stuff. So maybe separate let's first separate and then pass the actual world items. Um, Then this is the actual frame buffer associated with that. So we're creating the frame buffer over here. So it seems like we don't even need this right now, but this is some sort of debug rendering that I was having. Now if we sort of go back to main, this is some of the information for the world grid. So we have the number of columns, which is essentially going to be, we're starting off, it's going to be a ceiling value. So essentially I've initialized a grid square width, which is going to be 60 pixels. And so essentially we're going to go across two screen widths and divide it by 60 because that's how many number of columns we're going to have. And we're going to create a grid line for that. Now this grid line function actually, let's see the grid line. Over here essentially is just a grid line structure, basically holding where the grid line exists. The grid lines are just individual rectangles that are very skinny. And also this is just a direction specifying whether it's a row or column. Um, so that's that. Mm, Same thing with the rows. This is us creating the row grid lines. This is us creating the column grid lines. Let's see. And obviously this stuff will most likely need to be refactored because we can't have all this stuff happening in the main function. But then over here, we have a selected color, which I could maybe put in its own project defined macro. But anyways, this essentially represents, if I show this, you see over here when I'm hovering over a particular square that it's being highlighted. So it's essentially kind of being hovered. So it's not exactly selected, but it is kind of like the hover color, which is actually a better word, right? So over here, we'll just say selected color with hover color, actually. And so now, let's see, create a rectangular render. And so essentially, what the rectangular render essentially is, it's just essentially you could say a VAO, VBO, EBO for a particular object. It's basically a rectangle mesh. And the reason why I call it create rectangle render is because for I might have like in my mind it was just like a game object might be a rectangle and then it's associated with like a render, which would be the rectangle render, but then it's also gonna be associated with a transform, maybe a color, other stuff. So I kind of separated the idea of rendering the rectangle and its OpenGL aspects, uh, buffers, all that. Try to separate that from the actual game object rectangle. So over here, this is why it's called create rectangle render. Then over here we have the camera itself, which for the most part is just simple. Just if I show the struct, it's just a transform and also a position for where we're looking at. Um, X offset, it's let's see, this is essentially for the fact that, and this is something I would definitely have to kind of refactor a little, but over here, I can move left and right. I can kind of scroll essentially. And so in order for me to show in order for me to update what needs to be shown, I need to offset the grid a little. And so that's what the X offset is. It's to um especially essentially the scroll offset for the world world grid vendor. Let's see. Now the debug color is this blue. So this is a color for when you select something and then it's selected and you place the item. Now these are just temporary because obviously eventually when you actually select something and place a particular item, then it's going to be the image of the item that you're trying to place. But for right now, I just have it a color and I should also rename that to debug color to oh, it should be to selected color. This should be selected color. Mm, so that's that. Um, these are the world items, and these are essentially just oh shit. These are essentially just the items that you can choose from to place in the world. This right here is just a sprite sheet. I believe I was just using this for testing to make sure that the texture is working, like creating the texture, writing the texture, all that. Then this is the file browser for obviously browsing files. Then over here, this is for running the app, kind of initialize OnGUI for the current frame. We get the time since the start, process input. If the app has to stop running, then we stop running. Set a bunch of OnGUI flags and such. Let's see. Well, this is essentially just the fact that this essentially makes so the entire window becomes dockable. And so what this allows for is the fact that I can kind of, um, by default, all these items become dockable within this window itself. But then you can also place them within and all that, which is some of the stuff that iMovie just comes with in its docking branch. So that's that, and maybe I should kind of comment that a little um, for making the entire editor, dockable. This is not really necessary, but there's just something iMovie comes with, so you can see exactly all the features it has. Now this right here gets a little wonky. Um, let's see. So we start off with the menu bar, and essentially I kind of have this helper name for the namespace called conversion, but essentially what we're doing is we're setting the top left screen coordinate, and what we're doing here is that we're getting the window pause, and what this actually does is this will get the screen relative window position. So for example, this position, if let's see, yeah, let me kind of demonstrate. So over here, obviously this would be something like 0, 0, for example. But the screen relative is relative to this entire screen. So this, if you imagine this position over here, this is going to be different from if I move the screen or the window and now it's here. And like now it's different if I move it here. And now it's different if I move it here. And kind of show this if I actually, let me make sure IO stream is included. Yeah. Oh, and this is supposed to be IMVEC2, yeah. So just printing out the X and Y. So you can kind of see over here how it's 676, 125. If I move it all the way over, it becomes closer to like 1225, 224. Move it all the way up, 930. So you can see how over here it's like close to 0, 0, right? And this is the main bar that I'm talking about, the main menu bar. And so it kind of gives us like a relative because I couldn't find a way for ImGUI to just give the coordinates in particular places relative within the window. So we kind of have to get the screen coordinate and then kind of get the screen coordinate of the windows, sort of calculate that ourselves. So over here, this is essentially, let's see. And I'm not exactly sure how, let's see, I believe we can write a description above the function and it kind of, the IntelliSense kind of picks it up. So this should be set the screen relative coordinates of the entire window. Let's see. So now I think maybe if I go here, yeah, there you go. So, okay, so now we have like a little comment, which is obviously useful. Um, this is just to, oh, if I show, essentially in the menu bar, you have the option to open up a new world item. So add world item, then you can, here comes the browser, and you can kind of pick where you want the browser to be, or, oh, sorry, where the image is and whatnot. So you can select wherever version resources. So you can go in over here, you might have some character, I don't know, and then some PNG or something. Let's see, file browser to display if it actually needs to be displayed. And obviously a lot of this stuff, well, as I said, will be refactored most likely, but then this is for if something gets selected. Um, let's see, selected file name, clear selected, open add world item model. Okay, and then, oh, that just leaves, this is just another modal. Like once you select the actual path of the image you want, then you can kind of set some of its parameters and stuff. Over here is just the update function, which updates the camera, updates the X offset, which if you remember corresponds to essentially the offset of the world grid. And then over here, we essentially render the modal, which, oh, this is the modal for when you select a world item that you want to add, and then you want to select the number of squares wide, the number of squares high, stuff like that. So that's that. Um, and then update world items, essentially rendering the world items that you can select from to add to the world grid. So that's what this is. Get the world item, get the texture, kind of render that texture, as well as the title of that. And I believe if I'm not wrong, you can add something new. So if I go to world item and I go to resources, let's see, we maybe select a tree, then 1, and then we add it. So now you can see how there's a texture you can add. And obviously right now you can't place in the world, but that's the whole idea is what I need to do. Um, so that's update function. Let me also quickly grab that. Over here, should probably, this is going to be rendering the frame buffer texture for from the render paths used to display the actual world grid. So essentially, like I mentioned before, there's two render passes. One is to render this grid specifically, and then another is for everything else. So this grid, it gets rendered its own render pass, and then we render the texture itself, which it gets rendered to. So that's just what is being done over here. So you can see over here we have X ratio and Y ratio. Size is basically um, the size of the window in which we're going to render the texture. And the reason why we do this is because I want to make sure the entire world grid texture fits. So we just calculate the proper ratio. We render it. So over here you can see that there's a world FBO. In fact, world FBO is probably not as good a name. Maybe it should be named as world grid FBO or something. So maybe I'll do that, but I'm not exactly sure how I can do that in Hold on, let's see. Thinking we factor. Is there a renaming option here? Rename the world grid FPL. And so over here, that makes sense. That makes sense. That makes sense. Bind texture. We'll do over here as well. Apply. Now things should still work. Okay, now if the window's focused, essentially if we're on the window, then we're basically just updating over here. All we're doing is updating what is being hovered upon and if things get selected. So like for example over here, if grid square gets selected. And then over here we'll have window focused is um, hover grid hover logic, which I'll look into more after because obviously it's not perfect, but or I guess maybe I can kind of look at it right now. We have the grid square, we have the relative window mouse, region min, region max, which I believe these kind of just tell, um, I guess, the minimum position, the bottom top, and the top left and top right positions, if I'm not wrong. Um, Over here we have the top left, which once again, essentially what we're doing is we get the actual position, but this is relative to screen. But we need a relative to window. So in fact, we can also just, instead of doing this, we can just rename this to top left rel and rename it to top left win. And it should be top left win. Um, so then this is just converting to glmvec2. And then the other thing is now we convert it so that essentially top left right now is 0, 0. We want to make it so that the bottom right, or believe it's actually bottom left, so this function name is actually kind of wrong. But bottom left should be 0, 0, so we actually need to rename this. Let's see. Rename. So now that the bottom left is 0, 0, what would do? So that gives us essentially the position of the window, if I'm not wrong, relative to the bottom left, because I believe I made it over here. Just a note that screen coordinates will always be 0, 0 in the bottom left and screen width, screen height in the top right, just for a frame of reference to keep things consistent. So that's what this is. Top left window, right? So there's a top left coordinate for the window. Then over here we have bottom left window relative pos. So this would essentially be the position of the actual world grid FBO texture bottom left. So essentially what this does is this would be this position right here. Let me show you. That's this position right here, the bottom right. So Yeah, so we essentially go from here all the way down to here. And you can see there's kind of there's a magic number over here, the 20. And essentially I want to try to remove this magic number later, but essentially it's comes from the fact that when we calculate the position of the window, it gives us this position right here. So if we remove the height of the texture, which is what we're doing right now, right? We're removing the texture height. Problem is it goes down to here, but it doesn't take into account this little main menu bar. And so I kind of played around the numbers and saw that 20 works fine to get it to actual position. So maybe I can actually refactor that, but that's essentially where the number comes from. So we can say, as I define um, window, we could say window title bar height right now and say it's 20. Now, oh, this is just some debug information I was having for to see exactly where that bottom left position was being calculated to make sure, and that's what helped with calculating this magic number right here. Um, Now over here we have the texture relative position, which comes from the fact that we want to calculate within the texture where are we, and so we take the mouse state, the mouse position from the window, and subtract it from bottom left when relative pause. So this is where I think maybe the naming wasn't as ideal since the naming isn't that. So this should be instead we should actually rename this to what's something better to rename it as? Um, Bottom left world grid touch pause, which is a longer name, but I guess it is more informative. But essentially, we're kind of normalizing where the mouse is relative to the texture. And we can do that over here as well. We can say text rel pause to mouse pause rel. And over here, it's not being updated. Oh, it's because we didn't do dash yet then. Pause relative to texture. And so now that gives us the mouse position relative to texture because we're having the texture in its own render path, so it's kind of nice to have the mouse position relative to that. Then we get the expanded position, which is essentially just kind of scaling out because we minimized the texture, so it fits within the window. Now we're just kind of scaling it out so that it's almost covering the window essentially. And just makes some calculations easier because the x offset is relative to, it's assuming the world grid is being rendered on its entire screen. So that's why we expand it out. And we calculate which grid square is being hovered over. And we should probably rename this to grid square to hovered grid square. And oh, so over here it's being updated. So in fact, then what I'll just do is this. F2, okay, so we can just do F2. Um, Hovered grid square. Put elements in there. And then, so this gives a hovered grid square, and we calculate the position, which is essentially going to be the central position of the grid square, hovered grid square. And then this, if it gets selected, then we obviously create a rectangle render for that position. So I guess you could say this is actually the selection logic. Over here, I believe we don't need this anymore. fact, what I should do is let me run this to make sure everything's working fine. Yeah, so everything still runs fine. Let me actually. Oh, there should be a get. That's strange. Oh, is it because it's being recognized? It's Saturdays. So there should be a get. I'm not sure why it's not being recognized here. Let me try to. Can I? Okay, anyways, so we can do get add all, and then we have get status. Let's see if I clap. Okay. Okay, there we go. But essentially, what we can say is, let's see. And I mean, we only work on main right now. Added some comments and stuff, but I know we'll just add main and say, um, added comments for clarity. Now, what I want to do is remove kind of stuff that I don't need. So with this, don't think I need all of this. Over here, this is just some, we don't need that, that's just some debug logic. I believe we don't even need this stuff. Add line. Yeah, this is just some other stuff. Kind of moved it anyways. Then we render, and this will be the world grid render pass. Bind it, draw whatever rectangles are necessary, then unbind it. And then over here, once we now we're working with like the regular stuff and just drawing the ungui stuff, which is pretty much all we need. And then the debug rectangle handle. This is essentially just that debug thing that we're looking at, the red square that was showing um, the bottom left of the texture, which I can probably rename now to debug bottom left world grid. Okay, there we go. And then this is just updating time. So that is the main file currently. We can probably remove this. This right now. Kind of just trying to remove stuff that is unnecessary. And okay, okay. Do add texture selected. So I did texture select from. To do should be to place textures in the world map. I forget why this is the key state is elsewhere. I'm sure it's being external. I believe it's because it's being used somewhere else. No? Let's see, what can we also do with this? We can say we can just move it locally. Hmm. Maybe there was no reason, or maybe there was a reason, but then I forgot to move it back. Okay, so I'll move that back. Okay. And this debug thing should not really matter anymore. It is being externed referenced over here, which should not be necessary. So for now, I'll leave it, but um, should be fine. Hmm. Okay. The thing I want to work on right now is probably just selecting which texture you want to work with and placing it in the world. So create world item. Over here, get world item. So we have two structs for essentially that's the actual world item underscore t is basically just a world item that needs to be that you have the option of selecting, and place world item is world items that obviously have been placed. Um, world item handle. Let's see. Maybe I should update instead of calling this update world items. Maybe we should call it update world item catalog because that's what they are. I don't think I've done anything for placing world item. Okay. I don't think I've done anything for actually rendering place item. So for example, I think first thing I can do is just for debugging, I'll just when the left mouse is clicked, so over here. I know we're doing this. Maybe we should place world item, which in this case will be the world item handle, but there should be, let's see, okay, so right now it's being set to 0, 0, which is not what we want. We should be passing in uh position, right? So we should be having a transfer. Right, actually we need to import it. Transform.h transform_t, and this will be the grid transform. Make it just const reference for now. I wonder if there's a way for them jump to declaration rather than definition. Okay. So sometimes I guess it takes you to. Right, anyways, it doesn't really matter. We can just go to world h and place world item. Also take that. Which means position will be with transform x with transform y. Over here, this will take in, we'll just pass in 0 for right now. And then over here, we'll have the actual transform itself, right? So we're just going to be placing the 0th item just for debugging, and that would be the position we place it at. Now, oh, this should be transformed back to position. We also want to render these items because right now we were not doing that. World item handle. So this reference is just world item handle, which is just a reference to essentially a world item. Okay, we should probably have another function for render place world items. Which will essentially just be rendering the texture at the particular location. And if I go to Primeval, I believe over here, if I go to render 0 to basic, what should I render? It's going to be similar to this. We have the current transform, set the shader. Don't think I've wrote the shader for that, so I need to do that. So we need to write the shader for what actually needs to be placed. So let me do that first, I think. Shaders. We have rectangle dot frac, and it'll probably be pretty similar to this, to be honest. But let me just do it. We'll call this um, world items dot vert. It'll be similar to this. So over here, we're going to have in vec3 in color. Instead, we'll have text word. And this will be similar to this. Except we'll have and we'll have also a uniform sampler booty of texture. Texture, and you detect, and then Yeah, promote likely picture, texture, soft. Yeah, I take sampler and then the vector. Cool. So let's see. Now the thing is, we know the grid width and height because it's a square. I believe I have wrote a function. Let me see. I think in my maybe init over here init rectangle data. So this is the rectangle data. We create the vertices, the VO, VBO, EBO. Okay. Now I know these textures will be rendered on quads, and I believe I do have a function that created over here, like essentially calculated the mesh of the rectangle given a particular height and width. I believe I did that. Let's see, what is this function right here? Did that. So over here we do have the rectangle. And then when we draw it, hmm, okay, so I believe this, we get the rectangle screen size, which is we take NBC size to window size. So we know that the width and height of the rectangle is 1 in the just the OpenGL rectangle mesh data that I have. It's just 1 by 1. And what we do is we scale it. Let's see. Put internal transform. Let's be looking at okay. And then when we render, let's see what we're using. Oops. Great rectangle. So we're passing the actual width and height of the grid. Set the width. The window size. Okay, this works. So we get the. So we're not even using this right here. Hmm. I do know that. Oh, maybe I should also. So over here we have an internal transform. We have a transform handle, which essentially is where the rectangle will be on the world. But we have an internal transfer that is responsible for like scaling based on like the actual width height. of the rectangle, right? So I know that's what internal transform was used for. Now over here, just wondering why it's used in the actual scale, because if anything, it should be like width divided by rect screens rect width divided by rect screen size dot x, and then height divided by rect screen dot size dot y. Because essentially, if you have like the rectangle, if you follow my mouse a little bit, the rectangle is like this, right? But we actually just want it like this. Oh, I believe, let's see. Oh, I believe this had to do with the fact that in the orthographic in GLM, when you provide the coordinates, you provide the coordinates in in uh in pixel width and pixel height, and the matrices kind of handle the calculation, if I remember correctly. Because over here, when we have shader semi, so if we go into here, rectangle object shader, static OpenGL. Let's see, or if we have rectangle render G OBJ data. So I believe in init we are initializing the shader, and the shader is rectangle over rectangle dot frag, which over here using projection times u times model, but in the actual init function, in the actual, the model is um just one. But the orthographic projection is, or we have an orthographic projection that we set. Now, when we are rendering the the setting the model to the model matrix. So the view matrix, if I'm not wrong, I think the view matrix is actually kind of pointless here. Okay, I'll just pull up, I guess. I believe the view matrix over here is actually not being used. Let me see if that's true. It's just the model matrix and projection matrix. Hmm. Roller Grid FBO. I thought it was called Roller Grid FBO. It is. What's the issue here then? It is called Roller Grid FBO. Oh, you know what? Let me also just to let me unload this project. Hmm. Let's see. So it is world grid FBL. Hold on. I think sometimes, let me see. Sometimes VS Code requires you to clean and then build, or it causes issues. Let me try that. Hmm. Green. Hmm. Oh, so these things are. It is being updated. Why is it causing issues in here? Should not be causing issues. Please scroll the item. Okay, not found. It's right there. Or you know what? Probably include transform. Yeah. I thought forgot what we were even supposed to be looking at. But okay, these things are running. Um, yeah, I'm surprised it wasn't causing an issue. It wasn't able to recognize the struct. Hmm, it's weird. I feel like IntelliSense should have at least seen that. It's interesting. Anyways, um, What were we looking at? I believe we were looking at the rectangle render stuff. Oh, we were looking at the fact that view was not being used, and yeah, it renders correctly, so I don't think view is being used. And the only reason why it's not showing is actually if I go back to main, I disabled this. Sorry, so maybe I can do this. Let this here. Let's just what's happening? Hmm. Oh, wait a minute. View is being used. When the camera is being updated, it's probably being set. Hmm. Let's see where view is used. Maybe none of these are yeah, important. Other one. Over here. Yeah, so we do update the view matrix. There's the oh, and the transfer handle. And the view matrix is being used over here, and the render it gets updated. Oh, that makes more sense. And the view matrix is just the position of the camera. Hmm. It still doesn't explain why the width and height is this. Yeah. Oh, it's because the original rectangle is 1 by 1, but the orthographic projection allows for defining the width and height in its actual pixel coordinates. So if it's 60 by 60, then we scale it 60 by 60. Okay, that makes a lot more sense. So now if we go back to shape, now over here, this line makes a lot more sense. I don't know, maybe I'll comment that as well. 2D ortho projection represents in pixels and original direct mesh one by one. So that's why we also don't even need this. So scale rectangle mesh by rec with height 30. That makes more sense. Now over here, raw rectangle render. This is probably going to be used in the renderer. Yeah, exactly. And we're setting this over here. So it's just shader. Hmm. That means that now for the you can't have a separate renderer. The rectangle renderer right now doesn't even take into account. Really, the only need is just instead of color, just texture. Yeah. So we'll just and I believe this does that. In fact, what we can do is maybe we can just add it here anyways, because I don't think it'll matter too much. Because we're gonna be using the same, we can use the same rectangle mesh for solid color stuff as well as textured stuff. And so now we're using the same stuff for that. Now if we go back to init.cpp and we go to OpenGL data for the rectangle, we can sort of update this information over here. This will be at location 2, this will be 3 units wide, this will be vertex T, this should be text code, yeah, there's text code. Bottom right, I'm pretty sure these are flipped in some ways. We'll do 1 comma 1, or bottom right, we'll just do 1 comma 0, bottom, or top, oh, top right would be 1 comma 1, bottom right would be 0 comma 1, bottom left would be 0 comma 0, and then top left would be 0 comma 1, so bottom right would actually be comma 0. So now we can access all 3 locations in the VAL. We can have 2 shaders for right now. I don't think should honestly be the worst thing. Or in fact, what we can actually do is rectangle render. Hmm. Essentially, right now, all rectangles are being rendered with solid color. In fact, honestly, what we can do is instead of making this really complicated, let's instead over here we can just have we can instead just have uniform float. I believe can be used float for um text influence or something. So this will be essentially texture of. Now let me write this and I'll explain it. Uniform center flare. D of text, and over here we have in vector text chord. That's influence. Right, plus rec color. In the actual render shape renders FBP. Okay, we set the rectangle itself as a rectangle color. And we set the rectangle color in the OpenGL. Over here we have color, but we don't really need that. We don't really need this for the vertex. Oh, but we'll just keep it for right now. Keep it for right now. Um, because you never know in the future if we might need to debug something. It'll just be nice to hide that. But okay, honestly, for right now, it's fine. I was gonna say we can remove the color location in the VO, but to be honest, right now we'll just keep it. It's not that big a deal. And if we go back to rectangle frag, so essentially this will just be rec for this will be the text part, and then we'll have the color part, which will just be this. And this will just be the text part plus the color part. Okay, so that's for each rectangle. Now the rectangular render itself will now include that value, which will be um let's see, or should that be set separately? We'll just have it. We'll have a regular float text influence. We'll finish as a zero. Create rectangle render. This will just be text influence. Oh, it says this. Window dot text influence. Okay, draw rectangle render. So this is where you actually want to draw rectangle render, and we'll say rectangle frag the text influence would be rectangle dot influence. Why is this giving me an error? Oh, this will be. We do have a function for setting a float. Let's see if we do. We have set in, but we don't have set float. Um, believe I'm not wrong. This is just function need. You set the float, and we also add this to research.h. Float. Now, may not to do what's ratio here. False. Oh, real. Over here, I'm assuming over here is the same issue. Oh, these ones will be texture based. So this will be one. Oh no, no, right now they're not texture based. So this will be 0 as well. Right, so that's set. Um, 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 um. Right now this should be good. Let's see where they're coming from. This will also be 0. Oh, okay, so there's an issue with the linking, which I'm assuming I did something wrong in the shader. Oh, here we'll do that. Here for now, I'm just gonna remove color from all this. And instead just have so product fixed score line 15. Oh, Hmm. Not a word. Oh man. Okay, so now stuff is rendering. As it's supposed to. Why is that? Because of it? Let's see. See if that makes sense. No. We won't need probably those files anymore, but let's see what they shoot. Hmm. What that does. I feel like you may just. Why did I just do? Okay. Oh, this looks kind of cool, I'm not gonna lie. Also, I need to fix this issue. I believe that's due to maps, but okay, so something is going wrong before like over here. Oh, oh, because I renamed this to color. So I believe this should be color. There. Oh, it's red. Oops. There we go. Yay. Oh, so now, so now that's working appropriately. Now the thing is, should I include it? I'll just include the texture in the rectangle itself. Those textures with me this. I should have textures somewhere. Oh, let's see. Paste in OpenGL. After create texture, let's see, create the texture. How's it? Okay, so we aren't storing it. Where do we create? I don't think we created too much texture in this project so far. We're adding texture. And we also just have this test texture over here that we don't really need. And it just has an ID and all that stuff. You know what? Let's see. Here and then over here we'll have we have texture. We'll definitely do texture. We can also just store textures in an array or something, so we can have in texture and show the national to -1. We go back to we can create the texture and also store it. And over here we'll do instead of name. I'm gonna change texture again. The new one is just find texture for texture. Yeah. So right here, world item will be subtexture. Oh, how did I do that? Was it just? Oh, okay, cool. Bold backslash opens up on the right. It's pretty cool. Anyways, um, we don't have texture, we'll have texture handle, and over here we'll have texture handle. Let's create texture. Okay, oh, and this will be in. Um, yeah. Oops. Oh, first of all, we can move these. Theory. Now if we go back, rename this part of it here. Place word item. Text with no lines in that one. For color and type handle. Hmm. International rendering is a issue. Yeah. Picture handle thing. Okay. Oh, so if you is in render, and we draw the rectangle, and we bind the texture, and then bind the texture, something exists. So it's a if, then I'll maybe do this. Okay, cool. Yeah. Which means like here. Alright, so now we can actually place world items, which I will do after a quick break.